Dr. R. Sugurat Samuel is working as professor in physics in SRM University, Chennai. He is also training students for IIT JEE, AIEEE, and BITSAT. He has more than 16 years of academic experience both in teaching and research. He has published a book titled The Complete Handbook of Bachelor of Electronic Science Practicals. It is prescribed book in the syllabus for BSc Electronic Science by University of Madras. He has attended and presented papers in several national and international conferences and conducted many training programs and workshops. He has experience in both regular classroom teaching and also online teaching. His research areas are ultrasonics, polymers, crystal growth, and photovoltaic systems.
Welcome to UGC lecture series on Applied Sciences Electronics. We have been listening to a series of lectures on the subject Electricity and Basic Electronics for the BSc Electronic Science degree program. This is the 51st lecture in the series. This paper is the first paper in the first semester of the degree program. We have been learning about the concepts of electronics in this part of the series. Today's lecture is an important lecture because we are starting a new concept which is the digital electronics. In all the previous lectures related to electronics, we learnt about the continuously varying voltage or current. We have not limited ourselves to the value of current or voltage. Of course, based on the power rating of the components, there is an upper limit fixed by the current rating value. We will actually confine ourselves with the voltage or current based on the current rating only. But here in this lecture, we are going to learn about the digital world, digital electronics, in which the current or voltage would vary between only two values. So, there are lots of explanation, lots of definitions we could give for the concept of digital. But here in electronics, it has a particular meaning. All that we are going to learn in this lecture. How the analysis is done, what are the variables we would handle, what are the operations we could perform in digital electronics, we are going to learn in the upcoming lectures from this. So, let us see today's session outline for this lecture. In this session, we are going to see for an introduction to the digital electronics, comparison between analog and digital electronics, the different number systems, exclusively the binary number systems, and then the logical operations. First, let us get an introduction for the digital electronics. Though I have mentioned the voltage and current would vary between two values, but typically there is a definition given for the digital electronics. So, let us see what it is. The term digital is derived from the way in which the computers perform operations using digits. Initially, applications of digital electronics were confined to the computer systems. Nowadays, digital techniques are applied in many areas such as telephony, radar, medical instruments, navigation, military systems, and what not. Digital electronics involves circuits and systems in which there are only two possible states which are represented by voltage levels. In digital electronics, there are only two conditions such as current levels, open or closed switches can also represent the two states. In analog electronics, the signal current or voltage is in the form of continuous time varying voltage or current, which is in general called as sinusoidal. I hope now you got an idea about what is digital. The computers handle the data or even the entire operation of computer is based on the digits. So that is why the word digital has emanated. Initially it was related to the computer systems only, but now even for communication, even for printing, anything you take, it is done in a digital manner. What is the other electronics called? One is digital, which performs operation based on the digits. The other one is analog. Analog means it could vary, the current or voltage could vary based on the time for any value. It can have a continuously varying current and voltage. That was analog. Even the clocks we take, no, we call one type of clock as the analog clock, the other clock as digital clock. The digital clocks would have a digital display and which is controlled by mostly the electronic circuits, and the analog means it's more or less a winding type clock. Nowadays that is also operated using batteries, electronic circuits. But in the case of digital, it is the number that matters, but in the case of the analog, it is the continuously varying, may be indicated by the different hands in the clock. When we speak, no, our signal, the speech signal consists of lots of variations in the amplitude and intensity, which is an example for an analog signal. Even this could also be converted into a digital signal, the numbers, and it could be used for modulation and then propagation, and for all that the digital thing could be used. But one point we should keep in mind, digital means only two states, on and off, 1 and 0, a high or low value. That is the meaning of digital. Okay. Now let us see what is called the digital operations. What do we do with the digital circuits? How do we design the digital circuits? All that we are going to see further. Analog and digital signals are used to transmit information, usually through electric signals. In both these technologies, the information such as any audio or video is transformed into electric signal. The difference between analog and digital technique is that in analog technology, information is translated into electric pulses of varying amplitudes, of course in terms of the frequency also. In digital technology, it is into binary format, 0 or 1, where each bit represents of the two distinct amplitudes, namely a high and low amplitude. So this is what we need to keep in mind all about digital. Only two states are allowed, high and low. Here it is marked as 0 and 1. Even it could represent the two numbers 0 and 1, which could be a high and low value. The high could be a 5 volt value and the low could be a 0 or lesser than 5. Now we are going to have a look at the digital signal and an analog signal. It's a just basic representation, nothing to give an elaborate information about the concept, but let's have a look at the two pulses. So this is an analog pulse. Here the voltage is varying continuously as the time propagates. The amplitude is varying even to the negative value, but here the digital means it's a low value here and there is one high value and it remains in the high value for a particular duration and then comes to the low. Between the two high and low, no, there is no value possible. This transition is happening at an instant, very quickly it is happening. So the transition is not very much going to affect the operations. When we discuss about the transition from the low to high or high to low, we call that as triggers. Quickly it's happening, but right now at the elementary stage, let us not worry about the effects of the triggering. It's happening at an instant, at a wink of the eye, it's happening. So let's not worry about the transition happening, but the two states, it remains constant for a duration. That is important. It is between the high and the low value only. Now it's time for us to compare the analog and digital technologies and know more about the two, because we are going to learn lot about the digital techniques. So before that, let's have a comparative study. The features for the analog and digital are given in a table. When we take the signal, the analog signal is a continuously varying signal representing a physical measurement, but in the case of digital, the discrete time signals generated by the digital modulation between the two, high and low. Waves denoted by sine waves or sinusoidal waves, and here it is denoted by square waves. The representation uses continuous range of values to represent the information, whereas in digital uses discrete or discontinuous values to represent the information. They have given the example also, human voice in air, analog electronic devices, but here in the case of digital, it's computer, CD, DVD, all those are related to the digital technology. The technology itself, analog technology, records waveforms as they are, and in the case of digital, the sample analog waveforms into a limited set of numbers and record them. Even the analog wave is converted into the numbers zeros and ones, and it is recorded in that format. The data transmission, it is subjected to distortion because it will have a noise distortion, because the noise itself is the amplitude variation that's happening in the transmission, and in the case of digital, it is very much minimized because it is not going to affect the variation happening in the amplitude. The response to the noise, the way it responds, it's likely to get affected analog, but digital, it's less affected. Flexibility, the analog hardware is not flexible, but digital hardware is very flexible because it is operating between two states, and the uses, it's limited here in the case of analog, but here it is suited for computing and digital electronics. We have lots of such features for comparison, so I have just pointed very few, even that is also running for a long list. Let's see what further we have. The bandwidth, when we take analog signal, is the analog signal processing can be done in real time, and it consumes less bandwidth. There is no guarantee that digital signal processing can be done in real time and consumes more bandwidth to carry out the same information. Memory, stored in the form of waves, stored in the form of binary bits. Power, they draw more power. Digital instruments draw very less power. And the cost, which is very important here, it's low cost in the case of analog. The digital cost is high and is not easily portable. You may think the cost wise, once it is the implementation part is only very high, but the operation part is very less. The whole world is moving towards the digital world now, the digital technology. Let's see the concepts related to the number system, which are related to the digital technology after a short break. Welcome back. We have compared the analog technology and the digital technology so far, and now it's time for us to learn about the number systems that we use in the case of digital technology. What are the number systems we have for handling the digital signals? So, let us learn about the different number systems, and our aim is to get a grip over the binary system, the two variables, 0 and 1. So, we are moving towards that only. Before that, let us see what are the number systems available, so that we could come finally to the concept of binary number system. The computers can understand only numbers. A computer can understand the positional number system, where there are only a few symbols called digits, and these symbols represent different values depending on the position they occupy in the number. A value of each digit in the number can be determined using the position of the digit in the number. The base of the number system, where the base is defined as the total number of digits available in the number system. What is the meaning of base? The total number we use for the number system. We call the number system normally we use for the day to day activities. That number system is called a decimal number system, which uses the numbers from 0 to 9. Numbers available, it is 10 including 0, 0, 1, 2, 3 up to 9. When we count, we are using 10 digits or 10 numbers. So, it is called a decimal system. If we limit ourselves to only a lesser number of systems, accordingly the base will be less. What are such number systems available? When we use a number system which uses the numbers from 0 to 5, let us take for example, then that will have a 6, number 5, so including 0, 6 numbers we are using. So, it is hexadecimal numbered, like that. Octet, if you use 8 numbers from 0 to 7, 8 numbers when we use, that is called octal decimal numbers, octal number, not even decimal. Decimal means again it is 10, no. So, octal number, hexadecimal number, like that we have to use. So, let us see what are such number systems normally available for analysis. Each position represents a specific power of the base. For example, a decimal number system. So, it is taken as 10. Let us take this number 1234, consists of 4 digits in the units position, the digit 4 in the unit position, 3 in the tens position, 2 in the hundred position, and 1 in the thousandth position. So, based on the position and also the value of the number, each number is contributing to the value of the whole number. So, let us take the position of each number which holds here and try to calculate the typical value. See, this is how it is to be done. The 1 is in the thousandth position, 2 is in the hundredth position, 3 is in the 10th position, 4 is in the unit position or ones position. So, we multiply each digit with its particular base value. The base is 10. So, 10 raised to 0th position, first position, second position, third position. If we add, it has a typical meaning. So, as far as the digital decimal numbers are concerned, no, there is no difficulty for us. We know it by nature, because we know it by heart the value. Each position is by virtue itself the particular position or the base value is attached to it. We are used to it, but when we take up the other number systems, no, we will have some sort of difficulty in finding the value, because the base will differ. The base and its raised to the power, no, that will differ. In that case, typically we have to take a paper and pen and calculate the value it represents. So, let us see further the number system. To get strong foundation to digital electronics, we should understand the following number systems which are frequently used in computers. In the case of binary number system, this is our main aim. The base is 2, we will be using the digits 0 and 1 only. In the case of octal number system, the base is 8, the digits used are from 0 to 7. And in the case of hexadecimal number system, the base is 16, we will be using the digits 0 to 9. So, these 10 digits, along with that the letters A to F, A, B, C, D, E, F, those 6 letters are also used for a hexa number system or hexadecimal number system. Actually, it is hexa number system. How we say octal number system? Likewise, we have to call this as hexa number system. In the case of digital number system, we are using digital only 2, binary number system, we are using only 2, 0 and 1. So, let us learn more about the digital number system or the binary number system. The characteristics of binary number systems are the following. It uses the 2 digits 0 and 1, also called the base 2 number system. Each position in the binary number represents a power of the base 2. For example, the binary number is given like this here with zeros and ones and with a 2 as the suffix, which represents it is a binary number system, or else we will have a confusion whether it is representing the value 10,101 in the decimal system. One clue is it does not have any other number than the 0 and 1, but if a number 10,101 is to be written, this is how we have to write. We do not require any other decimal. So, to weed away with the doubts, we put this suffix 2 here to tell that this number is a binary number which uses only 0 and 1. What is the typical value of this 10101? To find out, we need to use the base 2 raised to the respective power and typically calculate. So, let us do that calculation to know the actual value of this number represented. See, it is done in this way. The binary number is 10101 and this is how we have to calculate. In the step 1, we take each digit and attach it to the base 2 and the power of 2. So, this is in the 0th power of 2, the first power of 2, second power of 2, third power of 2, fourth power of 2, like that it is written. Once it is done, it is going to be converted into a decimal number. So, we put a suffix 10 here. We typically calculate the value and finally find out the decimal equivalent, which is 21. So, 21 in the digital format is 10101. So, that is how we convert any number, any value, even a voltage or current, into a decimal format, into a binary format, the zeros and ones. Now, having learnt about the binary system, what next we need to do? Is there any operation that is possible with the binary system? How do we operate on them? How do we work on them? So, that is what is called the binary number system and the expressions in which the binary numbers are used. We need to learn about that. So, before that we will have a quick look at the binary representation of the other digits. It will just give us some understanding of how the number is becoming exhaustive when the value increases. In binary system, we use only 2 digits, namely the 0 and 1 as the numbers. Let us recall the binary equivalents of some decimal numbers here. From 0 to 10 we have used. So, this is how the number is used. As the number value increases, the number of digits in the binary is also increasing. So, we have some methods to handle this increasing number of the binary digits, zeros and ones. We will be able to club them together and convert it into some other concept called octets and XOR numbers. So, all these are possible when we learn more about the binary number system. Now, what are the expressions in which these binary numbers are used? As I have already stated, the digital world revolves around the two numbers 0 and 1. The 0 could be a lower value, low state, 1 could be a high state. So, between the two states only the operations are limited. What are the expressions possible? We may not be able to have exhaustive operations for this number system. We have a concept called logical operations, the true or false, on or off, like that. Between the two we need to decide. So, those are called the logical operations. We have lots of operations, logical operations. We are going to see them one by one in the coming lectures also, but this is a high time for us to introduce the concepts of logical operations. What is the meaning of the logical operation followed by logical expression? So, let us have a look at the logical operations. There are many logical operations that can only be used with expressions whose results are logical values. The logical values here are true or false. All logical operations have priorities lower than arithmetic and relational operations. In a mathematical expression, we can have an arithmetic expression followed by relational expressions and also the logical expressions. Arithmetic operations involve the addition, subtraction, multiplication, exponentiation, all that, and we have a rule called BODMAS rule, which is an elementary concept in the number system. And in those we have relational operations also, higher than, lower than, equal to, like that. And along with that we can have a logical expression like or, and, not, etc. These are called logical operations that could also be written along with the typical expression. But when we prioritize them, the priority comes after the arithmetic and relational expressions for the logical expression, logical operation. So, that is what is mentioned here. Now, let us see what are such logical operations possible with the expressions. Therefore, if an expression involving arithmetic, relational and logical operators, the arithmetic operators are evaluated first, followed by the relational operators, followed by the logical operators. This is the sequence we need to keep in our mind. What are the logical operations possible? Let us quickly have a look at the logical operations possible with the logical expressions. These are the different logical operations: or, and, not, nor, NAND, XOR, equivalent, not equivalent, like that. All this we will learn with examples in the forthcoming lectures. In this lecture, I have just given a brief about the logical operators. So, with this I would like to conclude today's lecture. Let us see the summary for this lecture. In this session, we have seen the introduction to digital electronics, comparison between analog and digital electronics, different number systems, binary number systems and logical operations. Let us test our understanding by answering these questions. Explain the difference between analog and digital electronics, mention different number systems, what is binary number system, what is logical operation, mention few logical operations. So, with this we come to the end of this lecture. See you in the next lecture with the logical operations possible in logical expressions. All the best. Thank you.